Good morning all, good evening, depending on where you are. Welcome to the webinar, Build, Manage and Automate a Secure PKI for your organization. Today the webinar is hosted by SecureMetric, PrimeKey and AppViewX. We have Yuvan from SecureMetric and Muralidharan Palanisamy from AppViewX to host this webinar for you. So just a few housekeeping rules before we begin the webinar. Any questions that you may have, please post them and we will take them towards the end of it. So over to you, Yuvan.
Yes, hi, thanks for the introduction. So basically the agenda for today is the changing rules of PKI, okay? And next we're going to cover what isn't working in the world today, the world of PKI. After we have covered that, we are going to move on towards what is needed to set up a typical PKI in your organization. And for those who already have a PKI deployed in your organization, we're also going to cover the migration. So for example, if you're due for a technology refresh, then you might want to come up with the latest and greatest, and so we're going to cover migration cycles, and finally, before we talk about the case studies, we will talk about certificate lifecycle management and automation. Yeah. So before further ado, I think I will hand it over to Murali to talk about the changing roles of PKI. Murali, over to you.
Yes, thanks, Yuvan. Hello, everyone. It's nice meeting you all virtually. So today let's look at how PKI has changed over the years, right? PKI as a technology hasn't changed much over the past few decades, but then the application of it has changed quite a bit, right? So if you look at the legacy PKI deployments, they were consumed by servers for SSL and TLS authentication. There were physical hardwares which use those for the ILO cards and the remote management, and there were Wi-Fi and VPN and email encryption, and there were maybe hundreds of certificates. Or maybe a couple of certificates per application, I would say. And then most of it was manually managed, and there was low volatility. What that means is the validity was like, there used to be a longer validity, 2 years and 5 years and whatnot, right? But because of digital transformation, the whole thing has changed with the new PKI, with the cloud coming in, right? There is a lot more certificates that are deployed with DevOps, tool chains, build and rebuild type of capabilities. There is completely, fast track certificates being created with containers. It is valid for like a couple of months instead of years and whatnot. And the IoTs and mobile devices have exploded the number of certificates. So now we are looking at millions of certificates per enterprise. And because of that scale, manual management, how we used to do, is not sufficient, right? And then the short-lived certificates, it changes the whole perception, right? Meaning with the mesh and containers and whatnot. And not only that, right, there is also a segregated issuers, multiple CAs, and it's a more, because of the frequent updates and changes, build and rebuild, there is more volatility in the certificates and in the environment itself because of the virtual machines and containers and all that. They live for a few hours, a few days and whatnot, right? So it's a completely different approach as it moves on. Right. Now, let's look at what isn't working with the PKI today. Right. There is a huge disconnect between, because there are such a huge deployments, right? Because of these new age deployments like cloud, IoT, and DevOps, which weren't there when we started off this whole technology when the current PKI was implemented. There's a huge change, right? And then the manual configuration errors are causing more challenges, and it is more distributed ownership, and that is causing delegation and access control issues. And then there is sort of what certificates issued versus what is there, not having that common visibility, right, and not having that common sync. That is another big challenge. And then crypto agility, like we have seen SHA-1 deprecation, we have seen migration from one PKI, like SecureMetric being deprecated, TLS 1.0, 1.1 being deprecated. So a lot of crypto is changing, right? The organization has to be agile to handle those changes, right? And then not having visibility into these short-lived certificates and whatnot, and not being able to automate and self-serve, causes outages per se, right? And what is an ideal PKI, right? An ideal PKI should have a flexible deployment, should have a software, hardware, or hybrid cloud-based deployment. It should have a CAVA, the validation authority and registration authority functionality. It should have the unlimited capability to generate certificates, right? And then it should support different certificate types and support HSM for high assurance. And then open source should support open source PKI and whatnot, right? And should have some open source capabilities in it. And then the most important is high availability and high assurance, right? These combined with some of the PKI automation systems or management systems like discovering the certificates, providing an end-to-end visibility, alerting, monitoring, and whatnot. And then a capability to self-serve themselves, policy and policy enforcement, and giving a level of vendor agnosty to move around, to migrate off if there is a need, and then third-party integrations like vendor versions to automate them, and a way to easily deploy. So PKI is complex, right? How can you have an easy way of deploying, easy way of maintaining them? This is a key requirement. And then it should be compatible with the latest technologies, with the cloud, should be able to deploy it as a cloud-native environment or an on-prem, or a hybrid if there are requirements that way, right? And then automation, right? End-to-end automation is another key requirement per se. So, Yuvan, would you like to talk about getting started?
I'll take it from here, Murali. Thanks, Murali. Yeah, so, well, we talk about setting up your PKI, right? So now I will always emphasize to start planning your hierarchy around your use cases. So usually when an organization engages us for setting up a PKI, we would first take a look at the use cases around the organization. So typically, what you see on the slide are a list of typical use cases that we discover in any large organization. The first one being network access control. So this is getting very popular these days, where you want to make sure that the machines that are logged into your network are actually authorized. So network access control is one of the big use cases that are coming up. The next would be deep packet inspection or data leak prevention solutions. So these are usually implemented among banks because most central banks have mandated this. And one way of another way of looking at this is actually lawful interception, where you actually inspect the web traffic or emails that are coming in and out of the organization. Okay, so if you're a bank, this is an open secret. I would say all banks do this, right? The other use case that still many people are surprised when I say this, but actually secure email, that's mine, right? Secure email signing and encryption using X509 certificates have been around since, I think, the year 2000. So a lot of people don't know that it is already supported by majority of the email clients and email servers. You can just do email signing and encryption, tomorrow if you already have a way of issuing and managing certificates. So this is something that catch a lot of people by surprise that they could already do this easily. The next would be single sign-on within the organization. So instead of using your username and passwords, you would probably use X509 certificates in your browsers as a means to log in to the different applications within the organization. One of the more niche use cases actually Windows Logon. So there are organizations that implement smart cards or USB tokens with X509 certificates as a means to log into their laptops or computers. So, they would eliminate username and password completely, and it's quite a secure way of actually protecting your digital resources. So another use case that banks should be familiar with, because again, most central banks have mandated that server-to-server communication, even internally, needs to be authenticated and encrypted. So the easiest way to do this, if you're running web services, is to just issue TLS certificates. So TLS certificates means you can do TLS secure, two-way TLS connections between your servers, even internally, and you don't require much changes actually to your applications in order to accomplish this, right? The next is client-to-server authentication and encryption. So if you're a bank and you have a client application dialing in to your host, there's also a mandate for authentication and encryption. And the easiest way to do this again is via TLS, two-way TLS, or even VPN. Yeah, and also, well, BYOD. BYOD is it was the up-and-coming thing, so now it's quite stable. So mobile device management solutions actually rely on X509 certificates for the authentication of devices. One of the other mandates from a lot of central banks in the region is the privacy or encryption of your files, not just in transit, but also at rest. So you are not just trying to prevent external data leaks, you're also trying to prevent internal data leaks. So if you have files lying on a file server somewhere, you would not want your administrators to be able to have access to those, right? So file encryption again, utilizing X509 certificates is a very good way of securing your files at rest. And last but not least, with the COVID situation around the world right now, so document signing is actually gaining in importance, and more and more document signing solutions we see popping up. You could basically convert your physical processes, which used to use paper, onto digital and have it digitally signed. Okay, and in some countries this is considered legally binding and as good as your handwritten signature. Yeah. So, after you have already gone through your use cases, you would actually consider a couple of things first before you can proceed to plan your hierarchy, right? So one of it is the certificate lifespan of each use case. So we actually mentioned earlier about short-lived certificates. So short-lived certificates are sort of a new thing. In the old days of PKI, you used to have certificates that are at least a year long, but now with use cases like BYOD, you have guest access, you have MAC, network access control, you start to have shorter lifespans of certificates. It could be minutes or even days. So this is one of the challenges of the modern day PKI. And the other thing to consider is, would you go for a centralized or delegated administration of your PKI? So some of the use cases actually requires a separate business unit to manage it, right? So, you would want to have a system that actually allows you to have delegated administration so that there's some level of autonomy to the business unit that's running their own business cases, right? Next is, will any of these use cases create huge CRLs or generate huge OCSP traffic? One of the common mistakes that we observe is that you would plan your PKI and you would discover that a particular use case is generating huge amounts of relocation data that is basically just dragging your entire PKI down because of the traffic. Right? So we want to avoid that, or rather we want to be able to handle that properly. Next, you got to think about which of the use cases have a super tight uptime requirement. So a lot of times you would see like, okay, I'm just going to issue certificates. It's not a big deal, I always have CRL as a fallback. So my PKI don't need like 99.9% uptime. But then suddenly you discover that, oh, I have this banking app that depends on this, and it has to use OCSP. So that's when you start, okay, maybe I need 99.9% uptime for my OCSPs as well. So, this kind of thing should not be overlooked, right? And next, you got to also consider the security requirements and the risk of each use case. So most banks would require inspection capabilities of encrypted data. So you got to plan this into your design of the PKI. Most organizations will also need recovery capabilities of encrypted data and keys. Yeah, so these are the things to consider. So once you have done all this thought process, you've gone through this thought process, you would come up with a hierarchy. If I can just go to the next slide. Sorry, I can't seem to. Hang on. Okay, I think there's a little bit of a lag. But once you have your hierarchy, it will look something like a pyramid. Oops. And yeah, let's skip the pyramid slide altogether. But then you would go ahead and plan your architecture. Okay, so now we are on the hierarchy slide. Okay, so once you have your hierarchy, you have already identified which are the use cases that need 99.9% uptime. You've identified which are the ones that generate a lot of CRL revocation data, a lot of OCSP traffic, and so on. Then you go ahead and plan your technical architecture. Okay, so the typical components of a PKI would be the root CA server. So the root CA server would be your trust anchor. It would be the thing that your entire organization depends on. Okay, so it's something that you want to protect very tightly. And next, you would then have issuing CA service for your different use cases. Okay, and you would want to have some sort of a registration authority or a CLM to manage all the different workflows of your organization. And you want to have a certificate repository. It could be in the form of your Active Directory on LDAP server. You want to have an OCSP server because most use cases require OCSP these days. You want to have HSMs to protect your keys. You would need a database, right? You need a load balancer. You need firewalls because usually your PKI is buried deep within your organization. And you will need a backup and restore solution to cover this. Okay. Okay, so things to consider. Does the root CA need to be offline? So there are a lot of arguments about this. And those hardcore security guys would say, yeah, your root CA needs to be offline. But the definition of offline is sometimes a bit too extreme. So, we usually propose for an organization such as a bank that it would be sufficient to just have it offline in the sense of not activated, versus offline as in unplugged and powered down. Okay, so something to consider. The other thing to consider is, again, can the certificate lifecycle management be delegated to multiple business units? This is very important to your operations later in the future. Okay, and you need to consider which applications need access to the certificate repository, because this would mean firewall rules and network planning. You would need to have looked at the performance requirements of the OCSP service. This is much overlooked. Then you need to consider how resilient the system must be. Should it be active-active or is active-passive sufficient? And how about disaster recovery? Do you need automatic DR failover? Right? And does every CA require HSM? So these are some of the thought processes that you need to go through before you finally come up with your grand architecture of things. And it can look pretty intimidating. It can look something like the diagrams you see on screen now. However, we do have a solution for that. So PrimeKey actually has a appliance. So it's an all-in-one PKI appliance that has the HSM database, key management, OCSP, CRLs, and backup restore, everything built in. So this really simplifies your technical deployment. Yeah, so what you'd be doing is you'd be deploying appliances instead of individual servers, OS databases and such. These appliances are also available as a virtual appliance, which you could then deploy on your VMware ESXi host, for example. And this really simplifies your deployments. Okay, so next, I think we're going to talk about the migration of your PKI. For those of you who have your existing PKI and it's time for technology refresh, I think we'll hand over to Murali to cover this topic. Murali, over to you.
So, yes, thank you. So, I'm sure everybody has a PKI deployed, right? And when you're looking to migrate or when you're looking to deploy the new next generation PKI, right? How can you seamlessly migrate from what you have, right? And what are the things to consider during migration, right? What are the questions to ask? The key aspect is, first of all, how are you going to manage the keys and the policies and define the process? Because you don't want to bring in the legacy over, right? And then, do I have the full visibility into all the CA certificates? Right? Is there a central inventory of all the certificates issued by CA accounted for to the devices? And what enforcement standards that I want to define, right? And I want to apply across the infrastructure. These are some of the base things that we have to define, right? We have to understand. And then what are the time requirements to migrate? Do you want to migrate as things expire to the new infra, or do you want to do it, as a one full go? So these are some of the things that you need to ask before migrating. And let's look at a sample flow. The key thing is, first is CA, setting up the CA or the issuing CA. And if you have an offline CA, setting up a new issuing CA. And then discovering all the certificates that are issued from the existing CA. And then figuring out a way to visualize the issued certificate from the CA to the end device that the certificate is deployed in. And plan the migration, right? How do you want to initiate that? Do you want to revoke an existing certificate, or do you want to issue a new certificate and revoke the existing one? Or do you want to just let it expire and renew it off the new issuer, right? Based on that, you have to have that flow defined and automated. And then once this is deployed, test and validate to make sure it is working as expected, right? And make sure it doesn't break any flow or any application in there. Now, what AppViewX enables is it enables you to do all those seamlessly with our application, the Certificate Lifecycle Management application. With that, you're able to discover all the certificates that are there in your inventory. You're able to discover certificates from any CA that you're using today, right? So all the certificates issued by the CA would be discovered and inventoried. And then you can also discover certificates from the end devices through a network scan or integration with Rapid7 policies and whatnot. So that you have a holistic inventory of both what is issued and what is used. And then you can manage those to define what you want to do with it, right? And then you can design workflow which will automate based on your business process. And then this enables auto-enrollment end-to-end to automate that whole process. And this combined with PrimeKey's all-in-one PKI appliance enables you for an easier management and easier deployment of PKI. Right? It's rest assured, high availability, high security, high assurance application. This combined with SecureMetric's PKI consulting, where they bring in their expertise and they look at your use cases, they analyze how you want to use the system, future-proof the system, and how to set up your middleware automation and define the policies. They bring in all their expertise and best practices in here. Anything you want to add here, Ewan? Ewan? Not able to hear you. All right, let's move on. I think so. We'll look at some of the case studies that we have deployed AppViewX successfully, AppViewX and PrimeKey in a couple of large deployments. One, we are going to look at a leading European bank where they had multiple Microsoft CA based on the different acquisitions that they had, and they moved to or consolidated to a central EJB CA, right? And then they also wanted to remove, they had a lot of manual process. They wanted to eliminate outages, and we want to automate the whole end-to-end certificate process. The other is a major biotech firm This was in the middle of COVID, where there were COVID lockdown, and where they wanted to enable remote working for all their employees, consultants, and contractors. And they want to do this securely with a client certificate based VPN. The whole process is to get the certificate. They had to come into an office network, which was not possible during COVID. Only with the client certificate they can connect to a network. So we solved the problem with AppViewX, also we deployed certificates on bring your own device with mobile devices and whatnot, and also automated client certificate deployment process and other servers, client and server as well, and we improved their security. So this European bank that we touched upon, let's look a little bit more in detail about what they have. So they didn't have a central certificate management system. They didn't have a central view as to how many certificates were issued, and they had multiple legacy CAs with multiple issuers because of different companies not being fully merged together. And then they had different PKI process because there were different PKI admins and different PKI users, multiple islands in a way. And then the whole thing that triggered this was an expiry. Right? So what we did post AppViewX and PrimeKey was that we migrated all of their Microsoft CA into a single appliance, and then it was streamlined with multiple issuers. They got 100% validity, and they didn't report any certificate outages since then. And there are hundreds of different teams using this for requesting certificate and automating. Some are automated, some are semi-automated, some are fully automated as well, right? And there are some self-service capabilities as well. In the next use case, in the biotech firm, so when they didn't have a secure way of deploying certificates to the endpoints. They had visibility. They had visibility issues. Then they didn't have a way to enforce policy, right? They had policies defined, but then there was no way to enforce it. And then the PKI had restrictions as to how they issue certificates, and most of it was done manually. One of the key benefits that we brought in is an auto deployment, right? Auto enrollment and auto renewal capability using EST protocol. And then we enabled their 100,000 users to connect using VPN, and each one had a certificate. And then we leveraged the CLM automation capability to end-to-end automate all the way through. So what is the benefit of an integrated solution, right? PKI and CLM. With the integrated PKI and CLM solution, you get a complete visibility, right? Complete end-to-end visibility. The key aspect is high availability and scalability. You can start from hundreds of certificates or thousands of certificates to millions of certificates, right? And you get top-notch security, right? So it has an embedded HSM which sort of secures all the certificate, all the private keys of the issuers and whatnot, right? And then you have a unified control. You have a better command and control of your environment, right? And then you get a fully integrated end-to-end lifecycle management system. And then the key aspect is you have the agility to changes both from crypto perspective and also upgrading the system and whatnot. So provides a pretty comprehensive solutions, all that you need from PKI and SCLM, or all that you need in automating or deploying a PKI in your environment is included in these two. We'll pause there and then we'll look at some Q&As.
Okay, thank you, Murali and Ewan. We will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions in the question box. And by the way, my name is Cherny, one of SecureMetric Technology's account manager. So there's a question here. What is going to be the impact of the cloud on PKI? How can we ensure? Sorry, Murali, go ahead.
Please go ahead.
Okay. And number 2, how can we ensure seamless migration when we have trouble with discovering certs? And another question from the same participant, can we help with more details on migration in the era of remote work?
Okay, sure. I'll take it one by one. I think first is the impact of cloud on PKI. See, the cloud has changed how we do business, how we do IT, right? How we do technology. Now, what used to take weeks or months to spin up a physical hardware is now minutes or seconds with the containers. So what this has done is it has brought in an explosion of the number of certificates, and then it also brought in a fully automated system. Now, cloud also brings in their own PKI, right? Like every cloud provider has some way, shape, or form offered their own PKI, either private or public, right? All cloud providers have a publicly trusted PKI nowadays. But then if you want to bring your own high assurance PKI to the cloud, right? That's where you would need a scalable infrastructure to support your cloud extension, and that is where AppViewX and PrimeKey comes in, where you can have your PrimeKey hardware in your on-prem where it is secure, and AppViewX CLM will extend it and automate it to the cloud so that all the certificate needs on the cloud is taken care from your PrimeKey appliance. And the second one was how to ensure seamless migration when we have trouble with discovering certificates. So that's a very good question. So again, especially in a segregated environment, segmented environments that I've seen, it's not easy to discover all the certificates, right? So that is where AppViewX has this capability to discover certificates from the issuers, which are the CAs themselves, whether it is a public CA or your internal CA. That way you have a full inventory of what has been issued at the at the source. So that enables you to securely take those and then address them as well. What was the third question? I'm sorry, it disappeared. Shwen, do you have the third question? It disappeared on me.
Murali, the third question says, can we help with more details on migration in the era of remote work?
Yeah, absolutely. So, in the especially in this COVID situation with folks working from home and then they're wanting to get certificates, right? So the biggest challenge is how do you handle that initial trust, right? How do you identify that end person and the end device? That initial trust becomes a big challenge. There are ways to mitigate it. There are multi-factor authentications that we could use, biometric identifiers and whatnot. And based on that, we can validate that initial trust and use that to automate that whole process. So there is a detailed white paper on that. We can discuss it further. Please reach out to your SecureMetric contacts, and then we can set up a detailed call to discuss that.
Okay, thank you, Murali. I hope that answers your question. And our next question is, how do we enforce policies when we have remote teams? This is very challenging for us.
Yes, that's true. This is an issue, and especially for endpoints which might not always be connected to the network. So this is where we have an agent-based approach where we use EST as a standard protocol, and we support agents for Windows, Linux, Mac, and whatnot. Right? Doing this for a server which is always connected is pretty easy, right? And if you're using Windows, we could leverage the Windows auto enrollment, or we can leverage our Windows agent as well to enforce and automate.
Okay, thank you, Murali. Our third question, most of the modern browsers now had dropped the support for key generation. How do PrimeKey and AppViewX adjust to this movement of the browsers?
Yes, so the way I answered for the previous one, right? With that agent, right, we would be able to automate the full process for all the services that is running on the system. So there are two ways that we can support where the key is generated in a central location, escrowed, and that key is securely deployed onto the end device. Or the key is generated on the device and it doesn't leave that particular device. And both our agent-based and agentless capability enables this. The challenge with agentless is that the system has to be connected to the network at least in some point of time to automate this process. And that works really well if folks are coming into office and whatnot. Otherwise, if they need certificates to connect to VPN and the certificate expires, they cannot connect to VPN, which means that they need to come to office to get the certificate. If it's an agent-based model, it sort of solves that problem, where irrespective of what it is, it can trigger a pull with the inherited trust in that particular case.
Okay, so it looks like we've covered all our questions. So if you have any question after this webinar, please email it to sales@securemetric.com. And as many of you know, SecureMetric is the Southeast Asia's leading regional player in the field of digital security, with core focus into software licensing, two-factor authentication, advanced identity and access management, public key infrastructure, and cryptography. SecureMetric has expanded strong local footprints with local establishment in Indonesia, Singapore, Vietnam, and Philippines. This webinar is in partnership with AppViewX and PrimeKey. Our partner AppViewX is revolutionizing the way NetOps and DevSecOps teams deliver services to enterprise IT. The AppViewX platform is a modular, low-code software application that enables automation and orchestration for certificate and key lifecycle automation, infrastructure orchestration, and IoT and DevOps security solutions. AppViewX is headquartered in New York, USA, with presence in the UK, Australia, and India. So last September 25, we had our webinar about the difference of digital signature and electronic signature. So if you wish to view the recording of that webinar, please email us at sales@securemetric.com. So our webinars are recorded. So if you wish to have access to the recording, please contact your respective account managers. If you have any inquiries, don't hesitate to send us an email. And thank you for attending our webinar today, and hope to see you again for our next webinar session.
All right. Thanks, everyone.
Okay.
Thank you. Thank you, everyone.
Thank you.